Thank you. All right.
Okay.
So let's say I'm a product owner, and I come
Mm-hmm.
to you and like, hey Phil, we need to um, offer promotion to our customers. So basically, we can do a marketing campaign or something, and we can offer some promo codes, you know, and then let our customers use those promo codes to get some deals. And so, how would you now collaborate with the product owner and then go into building this capability for the customers who have, and let's assume that the customer or the prospect has a promo code in their hand. Somehow they got an email through the blast or some, through some website. Okay, download, here's your promo code. Now, how do we work on this so that we can implement this capability where our system will be able to honor the promo code and offer some deals like a discount.
Mm-hmm. Okay.
Okay, so over to you. Maybe you don't have to. The idea here is not for you to finish this, right? But just to see how you go through this process of building.
Okay.
I want to learn about
Okay.
your philosophy, your approach, your way of working.
Sure. Okay.
And I'm
So
here.
if
I'm
you're
here as a
the
product owner. All ears. You can ask me anything, and we can collaborate.
okay, so okay, so we need to um, send promo codes, send promo codes to customers
Let's
somehow. I don't know whether this would be. So I'll
Phil.
ask you as a product owner, how are
Let's
we going
let's
to?
assume let's assume that they already the blast happened. They already have some promo codes. So
Okay,
so that part
so
was done by some other department, marketing, and now we are sitting here and assuming there will be some prospects or customers who will be coming to us and saying, "Hey, here's my promo code. What can you offer me? What's the deal?"
okay, so is there a shopping cart? Is there a website where they can buy our stuff?
Or let's not go there. Let's just say before you even start shopping, you just go and punch in the promo code, and it tells you, okay, so today, thanks to this promo code, on you get 15% discount on anything you want to buy, something like that, right? So to keep it simple. Before you even start shopping, it's just telling you, hey, with this promo code, you have earned 15% off today, or something like that. I mean, I'm just making things up, right?
Yeah, just an example.
Yeah,
Okay, so the user goes to the website, they enter in their promo code
yeah,
before they even do any shopping,
yeah. Just to
and
learn what is,
then
yeah.
and then
Then they can
the
decide,
website.
oh, looks good. But then it's the second step where you can actually apply that promo code, right?
Okay, it'd be nice to see your face at the same time
Okie doke.
because you're such a handsome guy.
Thank you. uh, I'm in better shape before, but okay, that's fine. I had my
No, you
I
look
had my
fine. You look good.
accident, with my hand and my black eye and all that.
Well, I can make it smaller if
Fight
you're
Club,
worried
yeah.
about that, but
I was
it's
in the
easier
Fight
to
Club.
understand people when you
Sure,
can
sure,
see
sure.
their
Yeah,
mouths.
yeah.
Okay. Um, so we want to apply. Okay. Now, do you want me to start writing pseudocode?
However you work, yeah, like you are
Okay,
the
because
you are the Mr.
because now
Builder.
I have to ask how many items now are we applying 15% discount to individual items or to the entire shopping cart?
Let's say it's on anything you decide to purchase, be it an individual item or the total shopping cart, whatever. This promo code today gives you 15% off your order total.
only today on your whole shopping cart.
Or maybe not
Okay,
today, but maybe there is a date, a specific date, or a date range.
discount until X date.
Yeah, so let's assume that this promo code has a shelf life, and it could be 1 day, it could be a week. It
Mhm.
it should be configurable, right? So that you can say, okay, we have this promotion happening, whatever, Mother's Day, whatever, and it could be 1 day, it could be it could be a date range, doesn't matter. And then people who have that promo code can punch it in, send it to us, and then we can inform them, okay, it could be a percent discount, or maybe let's say with just percent discount to keep it simple.
So this there would be a table called promo codes,
Right?
and there would be the code and the expiry date and the discount
Yeah.
percentage. Okay,
Hmm.
to start. Um, and the user enters in their code, and then we tell them what the discount will be. I mean, we should even tell them when it expires. Um,
Yeah.
tell the user when the promo code expires to put pressure on them to buy something with the code. Um, so then they put stuff in the shopping cart, and then they check out because, I mean, I'm not sure I see any other steps. They
Hmm.
put stuff into the cart, user checks out, checks out, and they choose their shipping and their destination, and um, then we have to apply the discount. And the discount could be per line item or it could be for the entire total. So this doesn't matter to you?
I think it amounts to the same thing.
Okay, so discount will apply to entire cart,
Yeah.
and its values is going to be, um, we just add up all the line items and then apply, and then we round it. We round it.
Yeah.
So like,
Basically, you can think about this when you reach the stage where it says pay now. When you okay pay now, you click. Now it's showing you, okay, so we are taking off 50%, 15% off your order total.
okay, so let's say they put two items in the cart. Item one is worth $100 or $59, and item two is worth, I don't know, $25, and then um, there's taxes and there's shipping. Shipping is going to be, I don't know, $10, whatever. Taxes depends on the state. I don't know. Depends on country, state, or province.
Yeah.
But let's say it's this is a total of, I don't know. Just give it a number like $8,
Okay.
and then the discount is going. The promo discount is going to apply to. Oh well, it could apply before the taxes. So I'm going to say applies to 59 plus 25.
Yeah.
So I'm going to use my calculator here. You can see my whole screen.
Hmm.
So come on. Oh no, that's calendar. Calc. 59. Oops. Okay, so now we go 59 plus 25 times, and then we're going to say, oh, unless you don't know how to use this. 59.25 times. If this doesn't work, I'm going to type some Ruby code. Fine, let's use some Ruby code. Oops, comment that out. Comment this out. We're going to do puts 59 plus 25, and we're going to multiply by 1.15. And then we're going to get a number over here, 96.6. And so, oh, no. The discount is 12.6. Okay, so promo discount is equal to $12.6. So then the total is 59 plus 25 minus 12.6. And then we got to do the taxes. Oh, and then wait, do we apply taxes to shipping?
So for now, just keep it. Don't worry about taxes and shipping. Just make sure that we get correct order total after applying the discount.
Sure. Okay. Then we're going to say that equals blah blah blah. So I mean, we can just do 0.85 really. But we can do 1.0 minus that, and then we'll get the final answer, which is 71.40. 71.40 without taxes and shipping.
Yeah, that's good enough.
Okay.
That's good enough.
Okay. Now this is simple math.
Yep. So you have basically created what we call confirmation example.
A confirmation example.
You know.
Okay.
Are you doing? Have you ever done extreme programming?
Have I done extreme programming? I've done pair programming.
Not extreme.
Maybe not.
So in extreme programming, we have what we did here, called the 3 C's. It is a card, conversation, confirmation example. So a card is a small physical card where you just write a single expectation, like, okay, this a promo, apply promo for discount. Then we went into conversation back and forth. You were making some notes, which is really nice, and that resulted in a specific concrete confirmation example, which I really like, which now you have concrete figures and values that we have in our hand, and we know what to expect. This is brilliant.
Okay.
So now that we are very specific, very clear, we can go into a little bit of making things executable. We move into the executable territory, right?
All right.
And so, knowing these values here and knowing what to expect, how would you approach doing something that is actually executing, running?
So actual code, you mean?
Yeah.
Okay. So,
by the way, so far this is beautiful. This is great. So far, what you did here is really okay. I like it.
Okay. Thanks. Because I wasn't sure if I was heading in the right direction.
Absolutely.
But
Perfect.
This is the way I work. I need to.
Perfect.
I need the best way is with a specific example, especially
Absolutely.
if you're talking to a product manager.
Absolutely.
And product manager might not do algebra,
Yeah.
X plus Y.
No.
Like they might not know how to do that.
Absolutely. And again, 3 C's is the really good approach, and I like it. You did it even without knowing you're doing it, but it's great.
3 C's. Okay, I gotta look this up.
Yeah.
I've not heard of
That's
it.
the
Okay.
extreme programming approach.
What was that confirmation? So what was that?
A card,
Or
conversation, confirmation example.
okay.
So basically, card is just entices us to go into conversation, like what we did. Like, okay, what do you mean? What are we promoting? What are we, And then
Okay.
eventually it boils down to a confirmation example where we know exactly what to expect.
Okay, great. Okay, so now if we want to turn this into code, um, then I would ask myself, now, then I would be talking to other engineers. I wouldn't be talking to the product manager
Yeah, of course,
anymore.
of course.
Probably not.
No need for it.
And
So
right,
you see,
and
here we have driven out any assumptions because it really this is what it is. There is no hidden assumptions here for later and say, oh, but we forgot. It's very clear here. Hey, given that we have these two items, these are the prices, and successfully apply the promo code. This is what I'm expecting to see. Very clear.
okay,
No,
yeah,
nothing ambiguous there, right? That's the beauty of it, right?
yeah. Well, you have to realize that I have been in the industry for more than 20 years. So that's why. So
Oh
this
yeah,
is normal for me.
absolutely. It's great. It's fantastic.
Okay. Um, so I think the first thought that came to my mind to turn it into code is there needs to be a service that understands promo codes. So it would be a class, and it might be called the promo service. Not everyone will agree with naming it that way, but the promo service is going to, and it's going to take as input, and it's going to have an interface. Now we could write a test first, right? We could, let's say we want to write a test. Then the test would be like, well, in order to write a test, we need to define an object and its interfaces, what goes in and what goes out. And so for me, the promo service, it needs to take as input. So, okay, let's say in English, promo service is given a total value and then returns a total value and a promo code and then returns a discount percent, for example. So like you could say, if there's a test and the test is describe promo service, and then it would, in Ruby, it would look something like this, and then we would say, it returns the expected discount for a code, and then you'd say s equals promo service dot new and code equals I don't know, that's the promo code, and then expect s dot discount percent to, or you could say percentage, but that doesn't really matter, to equal 0. Now we could, if we're dealing with percentages, we could do that, like as in a greater than, as in greater than 0 rather than a fraction. So this is like, well, it's a percentage, it's not a fraction. So and then I would run this test and it would fail because, well, the promo service doesn't even have this function yet. And it doesn't even have an initializer. So, somebody might want to slow down and just create this promo service object first, and then test that when creating the object that doesn't blow up. But I don't think that's that interesting. But that's debatable. I mean, if you think that's interesting. If initialize, it'd be code, and then code, 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 and then, or in Ruby, there's actually something like this.
Yeah.
Well, but anyway, so that would be that function, and then the public function for getting percent would be so percent, and then you'd say there's this table called promo codes, and so it'd be promo code, and in Rails it's singular, where code equals code, and first, yeah, let's do that for now, and then if record, well, actually, we could just return record, question mark, period, discount percent. Because if it doesn't exist, you know what? If record, then we return discount percent. Otherwise, if the record doesn't exist, then we return 0. But then, you might want me to write a test for this first, right? So, like, I could just, just do this, record discount percent, and then worry about the edge case later, and then I would write a new test where it returns 0 when there is no such code, and then I would type no such code, and then this would be 0, and then I would run this test, and it would, I forgot what this would actually do in Rails. Let's pretend this returns nil. And this would raise an error because you can't call discount percent on a nil object. So if I ran this test in Rails, it would throw an exception. So I would know that my test is failing. Yay, my test failed, good. So then I would say, if not record, return 0, otherwise that, and then I would run the tests again and they would both pass. So that's the way I would do it in Ruby on Rails.
Now suppose, just to throw you a little bit of a challenge, suppose we're not using active record.
Okay.
And so we want to process all that in memory. How would you do it?
In memory, okay. So then there would be a nice array of a nice hash, and there would be code ASDF would map to a percentage, and it could be other codes. Let's just do one, and then you would say record equals, well, you would just do homo codes code, and I think code here, and that would be it. Oh, no. But if it's nil, then you would return a result. If result, or you return either result or 0. Yeah, that would be the 2-line. I think that would be the simplest, the cleanest. I mean, this could be a one-liner if you really like one-liners. There, it could be like that. And this would be discount percent number 2. Yeah, that would be the new one, and the original one would be this one.
Okay, now, when as you are doing this, when do you get to the point where you are interested in seeing some feedback?
Well, I'm seeing feedback right after I write a test.
Mm-hmm.
and then I would run like I would write this test and then would fail. Red, right? Red, green, refactor,
Hmm.
red, and then I would make it. I would fix it, and then it would be green. It would pass,
Okay.
and then I would refactor.
So why don't we do that?
Because we don't, because this isn't running Ruby on Rails. This is just Ruby.
Well, let's just do it in Ruby. Let's not do it in Rails.
Oh, okay. So I can make a fake. Yeah, sure. Yeah,
Yeah.
I'll do it. Do you want me to comment out the code that isn't ready to pass?
Sure.
Like,
Yeah.
yeah, okay, sure. So we're going to make our own testing framework, and it's going to be, we're going to run a test. It's going to be run tests is going to be the function.
Can you not import a mini test or something from like a gem?
Oh, I okay. I'm not.
I think
I
mini
don't know
test
how
is
I
a
would do that. Our mini test.
mini test. Yeah, I think that's a gem. The gem that is the simplest one and probably the most flexible one.
What is going on here? Let me find local variable. Oh, run tests. Okay. All right. So we got mini tests here. I haven't used mini test in, I don't know, 15 years.
Or you can
So
use RSpec, whatever is you're familiar with.
okay, let's see if this works. Describe promo service. I don't know how to do this in a Ruby environment. Um, okay, let's really quickly Google. Use mini test. Then you can see my Googling skills. Start mini test, gem mini test, and then you do. Oh, then you make a class, and then you. I don't know if it's gonna run.
I think you should be able to use poros and mini test, and it should run. But anyway,
Okay.
yeah, maybe for next time, but we don't want to take too much up of your time.
Um, I mean, what do you want to discover? Because like I
Mm,
do believe in Red-green-refactor. I do believe in writing the test
sure.
first,
Okay.
making sure it fails, and then making it pass,
Cool.
and then clean up the
And
code.
so, why? Okay, let's talk about why do you think it's important to have the red phase, the failure.
Because you might write tests that are useless.
Hmm.
Um, I've seen people write tests afterwards,
Hmm.
and if you go and and if you go and purposely break the code, their tests don't fail. So what's
Oh,
happening is that they're writing tests which are not actually covering any logic. So if you write a test and it fails and you run it and then you fix it with one line of code, then you know you've got that one line of code
yeah,
covered.
yeah, excellent.
That's why it's important to have the test fail
Sure.
first.
And also another question, if you can maybe talk me about why is it important to refactor?
Oh, because code needs to be clean. It needs. I mean, there's many reasons. Like performance would be one, because you might not have the most efficient code. Maybe memory. Maybe you want to use less memory. But for me, the number one thing is usually readability. And if you have your tests written at the correct level, not too low, not too high, then you can refactor without rewriting your tests. And that's actually the most fun part for me. It's like, it's so enjoyable to take code that works and then make it cleaner and prettier and then run the tests. Of course, while you're refactoring, the test will fail a few times, but then at the end, your tests pass and you don't have to change your tests at all. That's like a wonderful experience, and I've had it many times. Um, because I often like to write the requests at the request level. If the model is very simple, I might write tests for it, but I might not. Because if you write tests at the model at this class level, and the class you decide to refactor it later on, you decide to rename it, or you want to move functions from one class to another class, or you want to combine multiple classes, then you have to rewrite all your tests, and that's a waste of time. That's why if wherever I can, I will write high-level request tests. They're called request specs in Rails, and they run quickly, and they allow me to refactor very, very quickly.
Okay. So, how do you uh, make sure that you don't paint yourself in the corner with tests that are brittle, that you write your test, etc., and then later on when you start refactoring your code, the tests break, and now you have to also refactor the tests. What is the approach to avoid that?
Thought I just talked about that. Let me think. What else can I add?
So, what I'm seeing usually with unexperienced developers is they tend to couple their tests to the structure of their code, and
Yeah, and
and you know,
you prefer that the behavior it be separated, decoupled from the implementation, right?
yeah. So, if you write your test by thinking about the expectation. I'm expecting the system to behave in a certain way, which basically means I'm expecting certain values. Then how that behavior gets implemented, the test really does not know, has no idea,
Doesn't care.
doesn't care. That gives you the freedom to go and completely gut your system and rearrange everything and do major surgery,
Mhm.
while as you're doing that and you're periodically checking, the system keeps behaving as you're expecting.
Yeah. Okay. So that's why I'm saying that there's a controller level of code, and then there might be servlets code, and then there might be model or active record code, and and this is the request level. So this is where I like to put my tests. Put my tests here, and then this can be refactored or renamed or replaced, and this can also be
Yeah.
same, right? So just in the previous example, you had me replace active record with well, one with a
Aura.
constant, really.
Yeah.
And so if I wrote the test, um, okay, at this level, this test would not be affected. This no, that's not true. This test would actually have to create the record in the database. Um, so maybe the test could have a separate section called that initializes the data. So like there could be a for do initialize the service, and and this would actually have to know about the implementation, but it could be mocked. So you could, in theory, set up mock data. That's one way of doing it. Like using mock data or stubbing. So I often get those ideas mixed up. But this is my favorite strategy. Have high-level tests that run fast, and then this part can be completely messed up, completely redone, and the tests will be stable. You won't have to change those
Okay.
tests.
Yeah, that's the intention. So, I don't know if you've heard of Ron Jeffries, one of the founders of the extreme programming. But one thing that he said that I think is very important. He says the trick is never to let the code not be running. Have you heard of that?
No, I
So,
haven't.
so that would be like the main or the the guiding principle when we are creating software is to never let the code not be running. But what does that mean? Why is that important? What do you think?
Okay, so for in the past maybe 10 years or more, the code, whatever code I wrote, would be running on a build server. Um, whenever I commit my code, it would be running on a build server, and all the tests would run. Um, and we would be deploying to production at least once a week. Um, so why is it important? Oh, why is it important? I guess I've taken it for granted. Um, if you only deploy, let's say you only deployed once a month, the problem with deploying once a month is that you will only be testing your code with production data once a month, and every deployment will be scary and risky. And if you break something, it could be very big. But if you deploy more frequently, like every week or preferably every day, then anything you break is going to be small, and you won't be afraid. And the risk of deployment will be, you're going to make mistakes. And if you make a mistake, it won't be disastrous. The customer won't be affected as badly. And then you can get quick feedback from the customer. Um, you might find that you deploy something that you think works wonderfully, and then you find that puts too much load on your database or takes up too much RAM, and you won't know unless you do this in production. And so the sooner you find out, the sooner you can fix your problems. Or it might not be a technical problem. It might be a business problem. It might be a design problem. The customer sees your new feature every day, and then they see something terrible or something's badly broken or there's something that confuses them. You will know sooner rather than later. And then you can go to the product manager, and let them know, hey, you know what? The customer didn't like this. And then you can change course. You can adjust your business plans sooner. Rather than wait a month and then waste a whole bunch of development resources writing code that the customer doesn't like.
So
Um,
let's
that
talk.
would be my understanding.
Let's talk about when is the code not running.
And is the code not run?
When is it not running? Obviously, he formulated this guiding principle because he noticed that there are periods when the code is not running, and he said the trick is to not allow that to happen. And so,
Okay,
when you
well,
think about when is it that the code is not running,
the code is not running if there are no customers, or if it's at nighttime, or um, yeah, if your app is running 24 hours in all the time zones all around the world, then maybe someone is always hitting your code. But then, unless you're getting, even if there's a 5 second delay between your requests, there's a 5 second gap when your code isn't running.
yeah, but
So you
that's not what he
could set
meant.
up a,
That's not what he meant. He meant the code is not running while we are making changes to it, right? Because if you have some code and you ran it and all tests pass and everything is okay and you didn't change anything, nothing changes. So next time you run, it's going to be behaving exactly the same way. But if you're making changes to the code, then it's not running. You have basically turned the engine off, and you open the hood, and you're messing with the engine. The engine is
okay.
not running. You know.
Hmm.
Then when you are done with your changes, you close the hood, and then you start the engine. Now it's running again, right?
Hmm.
So he was talking about the importance of shortening that duration of time when the code is not running, and he said the trick is to never let the code not be running. What does that mean?
Oh, okay. Some people like to automatically run the tests.
Yeah.
in the background
So
nonstop.
anytime
Or
tests, time tests are running, they're agitating the code, and the code is running. So he's saying letting that latency period pass is a risky thing because uh, code is text, and as you've demonstrated here, you can make all kinds of changes. Nobody's complaining about anything until the code actually runs. Then you may learn that, oh, we have a problem. This is actually tripping or crashing or wrong values, etc. So this kind of a latency period while we are making changes to the text is when the code is not running. That's what he meant. And so now the question is, how do we never let the code not be running, right?
um, yeah, okay. There's a utility you can use to make sure that your tests are. Hmm. Okay, I don't know. I don't know the answer to that.
Sure, no
I
problem.
do know that you can set up a utility that the minute you save a change, that the test will run immediately without you
Yeah, yeah,
purposely running it.
yeah. You
And the
can do it.
reason,
You can do it in Visual Studio. You can just write a little uh, script on save. You can do whatever you want on save, right?
yes, right.
I mean, you can do that. But the point is that changes should happen in extremely small batches. Because sometimes people tend to spend hours making all kinds of diffs to the source and never run the system, right? And then when they run it, all of a sudden a lot of things are wrong. Now they go and spend the whole day debugging, and that's wasteful, right?
Right.
But if you're taking tiny little steps, and with each step you run the code and you verify that nothing's broken, then you're actually being more productive. If you're frequently interrupting the coding session, right?
Yeah. What I'm used to doing is whenever I will push my code up to the build server every half hour. Maybe that's not frequently enough for you.
Mm-hmm.
Um, but yeah, that would be my
Yeah.
frequency of,
Now,
and that would run all the tests.
yeah, yeah.
Because when I do TDD, I'm only running the tests that are directly related to the code that I'm changing. But there could be other tests that are further away that I might be breaking, and I won't know until the build server tells me.
Yeah.
And and
Yeah.
I could run all the tests on my machine, but that slows down my machine, and
Yeah.
I don't want to be. I don't like that. So that's why I like to have a remote build server like Semaphore or Build Kite. Those will run tests for you.
So one problem we are seeing often is you have a team or developer, and they say, okay, this is done, and then we take it and we deploy it to some environment, and it breaks. So then they go and say, but it works on my computer. So the principle that I try to impose is like, you need to create a system that is immune to the environment. Meaning, you doesn't matter what environment you put it in, it works. So how do we accomplish that? How do we avoid?
One way people do that nowadays is by using Docker. Um, and so what Docker allows you to do is to to set up um, to set up these virtual machines that are the same on everyone's laptop. So you have a Docker file, and it defines these containers, defines operating system. It installs the same libraries and the same
I know,
everything.
but you see, that won't work because different environments sometimes, yeah, they have the exact same infrastructure and everything else, but the values in the configuration files are different. And that's why they're different environments, because you move from staging to whatever QA. And
Yeah.
how do we avoid that breaking, right? Because all of a sudden, oh, it's a different value, and all of a sudden something stops working. So that's one
Mhm.
challenge, right? Another challenge is when it works nicely with certain data set, right? You have a database with certain data, but then as soon as you promote to a different environment and it has a different value data in the database, it trips. So again, that needs to be avoided, uh, and we have to have a way, a clear engineering way, to create a system that is immune to the environmental variables, and also immune to differing data sets. And then the third challenge is to create a system that is immune to the order of the operations. Because sometimes I see people running tests and tests break, and then they comment them out. I'm like, well, why did it break? Because if the order of tests changes, then the system breaks. So the system should be completely immune to the order of the operation in the system, right? Because sometimes people say first this test runs, then that test runs. If you change the order, the tests break. This is a poorly engineered system, right? So these are the challenges that good software engineers know how to solve.
Okay. Well, I may or may not know, or it may be a habit, so I might not realize. But I'll tell you one thing: when it comes to the order of operations, if you're running Rails tests, if you're running RSpec and you're doing it the smart way, you will run the tests in a random order.
Random, yeah.
You should not be running tests from beginning to end. They should be in a random order. Yeah. Every time you run it, there's a seed. Like you can actually run RSpec, and then there's a seed value, and then you can like that. That changes every time when you run tests. But if you want to reproduce some weird error that only happens once in a while, then you can try and pick a specific seed, and then you can reproduce the randomness. Okay.
Yep. So the system itself should be completely not dependent on the order of its operations. And it's not like, okay, first you need to run this process, and then once it's finished, then you can run that process. If the system is designed that way, it's poorly designed.
Okay, so if you design your steps now, like if you want to make things atomic, you want to make those operations atomic, and you want to wrap them in transactions so that an atomic operation will either completely succeed or completely fail, and you want to decouple them from each other if you can. And let's see, what do you call it? Is there a name for it?
Decoupling.
Oh. There might be a name for the concept. I don't remember what it is, but I agree with you that you need to design your state machine or your whatever it is so that you might get user input in strange orders, in a strange way. Because especially if requests are coming from the internet, those requests could be coming in a different order than you expect because of latency, or their CPU is slow, or who knows what it is. So you need to just modern software needs to be able to handle events happening in unexpected orderings. That's just standard. But I don't know the name for it.
Well, it's decoupling basically.
Right.
Each operation should be independent and autonomous. Does not depend on other operations.
Right.
If it does, then it's tightly coupled and it's brittle, and the system is not properly designed or properly engineered. Okay. Maybe if you don't mind, this is great. If you don't mind, we can maybe have another session where, if you can get to the point where you can run those tests, and we can have them run. Because so far it's been fairly theoretical.
Okay.
And let me know if you get to that point when you can just have minispec or rspec running here, and we can see those tests running, and then we can push it through its paces.
Okay, sure.
Awesome.
Um, so like next week then,
Yeah, yeah.
Monday, Tuesday.
Uh,
I gotta check
up
my
to you.
calendar.
Up to
Yeah,
you when you get ready. No big rush on. I don't want to pressure you.
I will get this working. I will get the test working on Saturday or Sunday, whatever,
Okay, great.
and then
And then we can
and then
continue.
we'll set something up for next week.
Fantastic. Thank you very much,
Okay.
Phil. Have a great
Okay.
weekend, and
Thank you,
we'll.
Alex.
Thank you. We'll talk next week.
Okay. Take
Okay.
care.
You too. Bye. Bye. Bye.
Bye.